The 128 bits of an IPv6 address is comprised of 8 groups, often referred to as hextets, with each hextet containing 16 bits. IPv6 addresses are written as hexadecimal numerals. Since it requires 4 bits to write one hexadecimal numeral, each of the 8 groups are comprised of 4 hexadecimal numerals. Thus, there are 32 hexadecimal numerals in each IPv6 address. Sometimes that doesn't appear to be the case, because certain zeros can be left out. This will be discussed later in this video series. Currently, global unicast addresses fall in a range of addresses, represented by 2000:3. This would mean all global unicast addresses will start with the number 2 or 3. The first line states the global routing prefix used in this scenario. The global routing prefix, also known as the site prefix, is highlighted in gray. It has also been highlighted in gray to stress the point that some sources might use a different term for it. For this scenario, the global routing prefix as assigned by a fictitious ISP is 2001:5500:0055:/48. The first 48 bits are considered the global routing prefix. That's what the /48 represents. Note the first 48 bits can also be referred to as the first 3 hextets. The next 16 bits, or hextet, represents the subnet ID. It's important to keep in mind the 4th hextet represents the subnet ID. Deciding the subnet IDs is done by the network administrator. Assigning the subnet IDs for this scenario will be done later in this video series. When the 48-bit global routing prefix and the 16-bit subnet ID are concatenated, it forms the 64-bit network prefix. The distinction between /48 and /64 will be covered in even more detail later in this video series. But for now, realize that /64 is what's almost always used in the readings, labs, and configurations. The last 64 bits are considered the interface ID. The IPv6 network prefix is basically the same as the IPv4 network portion, and the IPv6 interface ID is basically the same as the IPv4 host portion.